everybody. It's week 4 of our energy exploration. Just so that you know, we are nearing the end of it. I think next week will probably be the last week that we are studying at least this form of energy. So over the last 3 weeks, I have asked you to engage in this scientific study of energy. And if you did all of the assignments, then you started off by creating a device that you thought would keep ice cold. And whether you knew it at the time or not, you were creating something to try to reduce the energy transfer between the environment and your ice cube. Next, I did a virtual demonstration to show you how ice melts differently on metal and wood surfaces, and introduced to you the idea that some materials are conductors and other materials are insulators. Last week you did a skateboarding simulation, watched videos, and read an article to move beyond just thinking about thermal energy to considering other types of energy that exist in the world, including chemical, kinetic, light, sound, and gravitational potential energy. Before we get into a deeper study of energy, I want to ground your learning with the central question. What patterns occur in energy transfer and transformation? At a young age, you learned about patterns. You were taught to make chains or stack blocks using pattern recognition, or to classify objects using patterns. So these patterns that you became exposed to at a young age started to help you make sense of the world. It allowed you to be able to make predictions. You noticed that you had dinner last night and you'll have dinner again tonight. That the sun will set and it'll get dark and then it gets light again. That the seasons are predictable. You get similar weather patterns in the winter, the spring, summer, fall. And with that knowledge, you begin to understand this world that we live in. The same can be said for our study of energy. As you begin to establish patterns, you can begin to understand certain aspects about how things work, and then you can begin to ask questions. And those questions will become even more important when things start to break the pattern that you thought to be true. In order to find patterns, don't do each science task in isolation, just to get it done. The opposite of isolation, or separated from others, is togetherness or integration. So, in other words, instead of completing each work as its own task, unrelated to the previous or the next task, look for patterns by recognizing the interconnectedness of everything that I ask you to do. I would like you to begin to notice patterns in our class data or in your observations about things in your house that you can eventually use those patterns to group or classify concepts about energy and then form predictions or recognize when things break the pattern. I'm making this video at this time because pattern recognition fits so well with what I've been trying to demonstrate over the last few weeks. Have you noticed the times that I've pointed out patterns? Have you noticed the questions I've posed as a result of the patterns I've found in your responses? So here's an example. I noticed the pattern in the success of your ice-preserving devices that used aluminum foil. That contradicted, or it went against, another pattern that I knew to be true. See, I already knew that metals in general change their temperature rapidly and tended to get hot out in the sun. Therefore, this caused me to pose an initial question, which was, how can aluminum insulate so well, which seems to break the pattern of metals being good conductors of thermal energy? By the way, I answered this question in depth in my video introducing last week's lesson. It was about a 9-minute video, so I don't want to go into more detail about that here. In my years of studying science, I've trained myself to look for patterns and wonder about those patterns. My training has helped me make sense of the weird things I notice and makes me curious about the things I can't explain. One thing I understand is that it's very hard to be interested in things or ask questions about things that I don't understand at all. So, for instance, I have very little interest in looking at abstract art. It looks like kindergarten scribbles to me, and I don't have a background in artistic understanding to even ask an intelligent question about the artist's choices. So, if I had a teacher who asked me to analyze this artist's work, my questions would be like, why did they choose the color red? Or, I noticed splotches. Is the artist trying to make a statement about minimalism, or are they just lazy? So, I get it when you have a hard time coming up with questions about science concepts. And with time and better understanding, you will be able to look at patterns and ask questions and genuinely care about getting the answers to those questions. I hope that in the last 3 weeks, you've engaged in energy activities with enough depth to feel like you have a basic grasp of what energy is and how it moves and changes form. My overarching hope is that at some point over the last couple of weeks, you've caught yourself wondering about energy, confused about how something works, or challenged by an idea. And if you've gotten that far, you're well on your way to asking probing questions that can lead you toward genuinely becoming curious about this branch of science. When you do your final activity this week, which will be to write a claim, evidence, reasoning paragraph, use this concept of energy patterns to demonstrate how the examples in the prompt connect to the other ideas about energy you've learned. Connect the patterns you observed in real life or have been taught to the examples I present in that activity. I want to challenge you to show me how you can connect the dots to make predictions based on your scientific study about how the world works. Have fun with the lesson this week, work hard, and of course, if you have any questions, reach out as they come up. Take care. Bye.